Lesson 8.1 is parabolas. Officially, it says parabolas review. The parts of this review are that you guys have talked about parabolas since algebra, but a lot of what we're doing is also new. So, what do you guys know about parabola? Okay, U-shape. What are pieces you know on this parabola?
Minimum.
Okay, what is that minimum called? It's the vertex, yes. So parabola has a vertex. It technically could be either the minimum or the maximum. Or, as of today, we can also go left or right instead of just up or down. Okay. And then what else do we have on a parabola? We have the vertex. What goes through the vertex? Axis of symmetry. Okay, so those are the pieces I would expect you walking in. You dealt with parabolas in Algebra 1, you dealt with them in Algebra 2. I would expect that stuff to be familiar. Now, as you look at this picture over here, okay, so I tried to put a nice, decent picture in here for you to have something to refer to. So as we see this parabola, we've got our vertex. The vertical dotted line is our axis of symmetry. A few new pieces as well. We have something called a focus. Okay, so our parabola has a focus, and it is a point that is inside the parabola. Now, that focus is inside the parabola. On the outside of the parabola, we have a line here, and it's an imaginary line, just like the axis of symmetry, that is perpendicular to the axis of symmetry, called the directrix. Okay, so what's important to realize about this point called the focus and this line called the directrix is that they are equidistant from the vertex, meaning that the distance from the focus to the vertex is the same as the distance from the vertex to the directrix. Okay, and that is, you'll notice on my drawing, that is called the focal length. Okay. Besides that, we also have a focal width here, which is the line that goes through the focus. I'm trying to think, what did I miss? Okay. And then the other thing I should say here is that when we draw a parabola, okay, officially a parabola, they're on a parabola. The parabola is all points that are equidistant from the focus and the directrix. So, for instance, the vertex is the same distance from the focus and the directrix. Well, all of these points on here, if drawn properly, are at equidistance from the focus and the directrix. Okay, and that's the idea of how a parabola works. We'll talk when we go in and talk about ellipses and hyperbolas over the next few days. I'll talk more about how they're conic sections and where they can't come from, but that's some basics here. You'll also notice you have two columns of information here, yes? The difference is, if you look at the direction, this left column of information is all the information you need for a parabola that opens either up or down. And now that we're in pre-cal, the second column of information is all the information you need for a parabola that either opens left or right. Okay, and I'm going to go through with you how we use that information. You'll notice at the top of each column there is an equation. So this is what the equation looks like if my parabola opens up or down. This is what it looks like if it opens left or right. Okay, vertex is the H and K in there. You've heard H and K before, right? That's not new, so that's your vertex. We've got some other formulas in there, and we'll talk about them as we go through things. I will tell you from today, day one, you will be provided this information on your test. Okay? Because, and here's what I'm going to tell you guys, this is just the parabola. We still have equivalent information we have to gain from ellipses and hyperbolas. And there is a lot of information. Okay? So you will be provided, I would say a page of notes, but it ends up almost being a packet of notes by the time I get all the information together for you. But I'm just going to provide it as is right here to you for the test. So, and I say that partially because I'm the one that's been doing this, and I feel like I would struggle to keep all my formulas straight. So you guys as beginners, there's no way I can expect you guys to keep it all straight. So, yeah.
So we're going to get information of the parabola and then information of the ellipsis and the hyperbolas.
Mm-hmm. Yeah. If you, and I saw some of you already have, if you flip to the front of the ellipse page, there's a chart, right? If you flip to the front of the hyperbola notes, there's a chart. So, and actually there's 2 under the hyperbolas and 2 on the ellipses. So I'll provide it all though. Easiest, I decided that was easiest several years ago. It's a lot. It really is. So, okay. So you're going to want to have this chart handy. Okay. You're going to see me refer to it all throughout this lesson. Example 1. A lot of what we're being asked to do is to write an equation. Okay. So we're being asked to write the equation of the parabola given the following information. So as we look at A, we know this parabola has a directrix of x equals 2, and its focus is the point -2, 0. That's what they're giving me. And they're saying, okay, write an equation. Now, a couple of things. One, you're going to see me suggest you draw lots of pictures. Okay? I'm not saying everyone's going to have to draw pictures to do these once you start to understand them better, but I think it's a really good beginning point is that we draw pictures. There's also some other things because you need to always be able to figure out what I usually say is this a left column parabola or a right column parabola? Do you understand what I'm saying here? In other words, does this fall in, is this information going to lead me to think, okay, it's this parabola in the left column I'm going to write an equation that looks like this, and the parabola opens up or down? Or is it a parabola that falls into this column of information, and it's going to end up opening left or right, and the equation is going to look like this? Okay? Has anyone seen it? Because honestly, you can tell whether it's left column or right column without drawing a picture. How can we tell by knowing the directrix and focus? Or even honestly just knowing the directrix?
It says that x equals 2, so I'm guessing it is the right one because it's x equals 2.
Okay. Look at your directrix equation, guys. In the left column, it's y equals something. In the right column, it's x equals something. What is my directrix here? X equals something. So which column am I working with? I'm working with the right column. Okay, so that's one way to tell. The other thing, and we're going to do this because I want you guys to understand relationships, we're going to draw a picture because that will also help you. So if I'm just going to sketch. Okay, so there's my x and y axis. I haven't drawn anything fancy yet. Let's put on this graph what we know. The directrix is x equals 2. What is the directrix? It's a what? Is it a point? It's a line, right? So what does the line x equal 2 look like? You go to 2 on the x-axis and what? Draw a vertical line. So this directrix is going to be vertical. They also told me the focus is -2, 0. So there's my focus, there's my directrix. Now that we've drawn that, can you figure out which way this parabola is going to open? Why? Okay, so he says it opens to the left. Does that make sense to you guys? First of all, that vertex has to be in between the focus and directrix, right? So I've got my focus and directrix, it has to be in between them. And then that focus is where? That focus is going to be on the inside of the parabola, right? Can you tell me where the vertex is?
It's going to be on x equals 0.
Okay. Yeah, more specifically the point 0, 0. How do I know my vertex is at 0, 0? Yeah, remember my vertex is equidistant from the focus and the directrix. So that puts it 2 in each way, so my vertex is at 0, 0. I'm just sketching a parabola in here. Okay. Again, I'm not saying you had to draw a picture to do this problem, but I think it helps, especially at this stage in the game. Okay, so let's gather some information here. First of all, you told me the vertex ended up being at 0, 0. What letters are those going to represent in my equation? H and K, and it tells you that in both columns up above, doesn't it? Now, I should have written down the equation. Which column did we say we were in? We said we were going to be in the right column. Does that still make sense? This parabola ended up opening left, didn't it? So that puts us right here on a parabola that opens left or right. So look at this. Can't see it right there. Y minus k squared. Well, y will say y. Do I know k? Yeah. 4p. We don't have p yet, so we're going to have to figure out how to find p. And then x minus h. X will say x, and we already know h. So there's always 3 things you have to know. H and k, so your vertex, that's 2 things, and then your p value. So my job now is, how do I find p? What were we originally given? You're originally given our directrix, yes? And I'm not ever going to argue there's only one way to find P here, okay? So if you find P a different way, that's fine. But I'm going to suggest that we use the directrix. We know our directrix is x equals 2. What's the equation up above say for the directrix? Now we're in right column, so x equals h minus p. Think about it. If the directrix is x equals 2, and the directrix is x equals h minus p, then that means h minus p has to equal 2. Can you agree with that? If x equals 2 and x equals h minus p, then they equal each other. And what do we already know about h? It's 0 because it's part of the vertex. So 0 minus p equals 2. Well, if 0 minus p equals 2, what's p? Negative 2. Yep. Because negative p equals 2. And then divide by the negative. If we get technical, well, I'll save that for the next one. Okay, you ready to write your equation? We were right column, so I'm going to write the formatting down. Y minus k squared equals 4p times x minus h. So, what do we already know? What's k? 0. And what's h? 0. And what's p? Negative 2. Okay. Y minus 0 squared. What's a better way to write y minus 0 squared? No. If it's y minus 0, that is just y, so y squared. 4p. 4 times negative 2, negative 8. X minus 0. X. So we have the equation y squared equals negative 8x. Now, try to make a connection here. If I would have asked you what's the equation of a parabola before today, what would you have said? Y equals x squared, right? So y equals x squared is a parabola that opens up or down. What makes it open down? Negative x squared, yes? Okay, so now, if this is a parabola that opens left or right, instead of it being y equals x squared, it's going to be, how do you say? The square flips, right? So instead of it, the square being on the x is now on the y. So what's that negative on that 8 doing? This negative makes it go from up to down. X equals y squared is your basic parabola that opens to the right. Right kind of compares with up. Left is going to compare with down. So when you throw a negative in there, that means your parabola opens left. Okay, so if it's a parabola that opens left or right and you get a negative p-value, realize that parabola opens left. Now, this equation found p to be negative. Beware, there are times that you have to pay attention and realize p needs to be negative. Okay, depending on how we do the problem. Questions there? Is that okay? I know it's a whole different set of expectations, rules, and everything. So, okay, moving along. Let's try the next one. I'm going to tell you guys that chart up above is going to be your best friend if you learn to use it. If you try to use it, okay? Because it has everything you need there. Okay, vertex is 3, 4, and focus is 5, 4. Again, honestly, you could do this without drawing a picture. I'm going to suggest we draw a picture to start because I think that ties it in together. So let's see, 3, 4, 5, 4. I'm just going to draw a picture here, and I'm just going to do first quadrant because I really don't need more than the first quadrant.
You still draw pictures, or is it mainly just going to learn how to do it?
If I'm just doing it for myself, not necessarily. If I'm doing it to teach, then yes. So, if I'm doing it on an answer key that you guys might be using as a guide, then yes. Okay, vertex is, 3, 4. Focus is 5, 4. That's what we got. What can you tell me based on looking at that picture? Do you guys see his point? Okay. Here's the key. What's the distance from the focus to the vertex? That is a distance of 2, yes? And remember what? The vertex is equidistance between the focus and the directrix. So right here, if my vertex is 2 for my focus, then on the other direction, my directrix is going to be over there. Now, he said at 1, 4. Technically, it's not a dot, though. The directrix is it's a line. So in this case, it's a vertical line that would go through the point 1, 4. I totally get why we're saying 1, 4, though, because that's the point you have to reference. Do you know which way the parabola opens? To the right? Because that focus is inside the parabola. That's the key. Once you know where the vertex and focus are, that tells me. Okay? And honestly, I'm putting more in this sketch than you'd even have to. But now, how how else is that distance between the vertex and focus important? Because just by drawing the picture, we have all the information we need, in my opinion. If you look up here, what is the distance between the focus and vertex called? Focal length. Look at your chart. What's it say the focal length is? P. So what did we just figure out by counting the distance between the vertex and the focus? We learned that P is a distance of 2. Now, I will warn you if you do it this way. You have to stop and ask yourself, is P going to be positive 2 or negative 2? What would you guys say here? Positive 2 because this parabola opens to the right. If it opened to the left, there's nothing telling me negative other than I have to realize, oh, it opens left, I have to put the negative on there. Okay? Now, we know P is 2. We also know a vertex. The vertex was 3, 4. What does that tell me? 3 and 4 are my H and K. Now, I don't know if you're okay with how we found P, that we counted, it's the difference between the focus and the vertex. I'm perfectly fine with that.
Not always work.
Yes. Okay, so but you have to know the two of them or be able to figure it out. Now, here's the other thought. If you don't like how I found P, here is a more like paper and pencil way to find P. Okay? Look up in your list up above. Now, first of all, I don't think we ever discussed, am I a left column parabola or a right column parabola? In other words, does my parabola open up or down or left or right? It opens right, so I'm over in the second column, however you want to put it here. Maybe I shouldn't use the words left and right. The second column, okay? And what's it say about the focus? The focus is H plus P comma K. Okay, so here's how you could use this. The formula for my focus is H plus P comma K. What's my ordered pair for my focus on this problem? 5, 4. You see where I'm going with this? We already know K is 4, don't we? But now you know that H plus P is the same as 5. And do we know H? Yeah. And so you can kind of set it up as a little equation. H plus P equals 5. So H is 3. So 3 plus P equals 5. And so P is 2. And notice, P came out to be a positive 2. If you're doing that type of, like the algebra, it will tell you itself if it's positive or negative. Okay? Ready to write an equation? Again, it was second column. So y minus k squared equals 4p times x minus h. And what can we fill in? K is 4, P is 2, and H is 3. I went the wrong order for all you guys, didn't I? Sorry. Okay, can you write your equation? Y minus k squared now becomes y minus 4 quantity squared. 4p is 8, parentheses x minus 3. Okay. Another way, if I wouldn't have drawn a picture, and I don't know how you guys are feeling about my pictures, whether you love them or you hate them, but notice my vertex and focus. They both have the same y value, yes? So another connection up here is if I look up here, vertex is hk, right? Focus. Over here it's h comma k plus p. So in this column, the first number would be the same between the focus and vertex. Over here, It's H plus P, but they are both Ks. So the second number is the same here in between the vertex and focus. Lots of different ways you can do these problems, okay? So you have to work to find the connections that you like. Okay, you ready to try C? Opens left, vertex negative 3, 2, focal length is 2. If I wasn't trying to teach it, I could just write my equation right now. Everything is given that you need. Okay? So if you can see it, that's great. For the rest of us, let's talk. Okay? Again, do I have to draw a picture? I'm going to. What do I need? I need second quadrant here. Okay, so we know there's a vertex at negative 3, 2. We know it opens left. So goes something like that, right? And we know the focal length is 2.
This time it's on order clear.
Huh?
So this time it's on order clear.
Well, that's the focus. It would be the ordered pair. The focal length is just a number. How can this help me?
Well, you just go to each side to find out. So like go to the left.
Yeah. Yeah, look at your picture up above, right? What is focal length? Focal length is the distance from vertex to focus and vertex to directrix. And so that means that if there's my vertex, if I continue to go 2 to the left, there is my focus. If I went back 2 to the right, that would be my directrix. Because they're supposed to be evenly spaced, right? So what does that tell me? What is that in my equation? Yeah. If this distance right here from focus to vertex, or vertex directrix, that tells you P, right? Focal length is 2 tells me P is some kind of 2. What's the catch? Why would it be negative? Yeah. So because it opens left, then we're going to have to use P is negative 2. Okay? I don't have an equation here that I can plug into and get it to tell me P is negative 2. You have to recognize and acknowledge, oh, it's opening left. I have to throw the negative on there. Okay? So we know P is negative 2. We already have our vertex, right? And our vertex tells us which letters? H and K. Okay. Ready to write an equation? I'm going to write out the form again. Again, it's the second column because it opens left. So y minus k squared equals 4p times x minus h. So y minus what?
Y plus 2.
The y value, so k, which is 2. And realize when it's y minus, that's always going to be the second number in the vertex. Okay? That way, if you don't want to think h or k, just y goes with the y coordinate. 4p, what am I going to use for 4p? 4 times negative 2, which is negative 8. X minus h is going to become x minus negative 3, which is x plus 3. Okay. My timing's not good today. Let's flip to the back. The front side was pretty much paper and pencil work, right? There was no calculator needed. The back side is officially calculator because if you notice what it says graphing a parabola on a graphing calculator. What has to be true to graph something on your calculator? It has to be y equals. That is the challenge here. Okay? You're going to solve for y. Notice the little hint. Sometimes you might have to complete the square. Okay? You're going to type the equations into y1 and sometimes also y2, because remember when we take a square root, there's a plus or minus, and then you graph it. So, let's talk about as much of this as we can before we run out of time. A, y minus 4 squared equals 8 times x minus 3. My goal is to get y by itself. First step to get y by itself. Square root. When you see that y minus 4 quantity squared, square root. If I square root the left, square root the right. So on the left I have y minus 4. On the right, it's going to be the square root of 8 times x minus 3. And you can just leave it. It doesn't have to be multiplied, together or anything. What do I have to put in front of that square root? When you take the square root in an equation setting, you have to consider the positive and negative roots. And then if it's y minus 4, we're going to have to add 4. And so this is y equals 4 plus or minus the square root of 8 times x minus 3. Okay? You've got the y equals here, right? So as you're going through and doing homework tonight, first of all, me seeing the work, that shows that you solved it, yes? The other thing when it says to graph it, sketching a graph on your paper of what you see on your calculator is what shows me that you graphed it. Okay? That's the work I'll be expecting to see. Now, did you guys look at the original form? Can you tell me what the vertex would be before we ever graph it? Okay, with the x value is the x coordinate, so since it's x minus 3, it's going to be 3. With the y is the y coordinate, so it's going to be 3, 4. Okay, so now when you type this in on your calculator, what's the trick? Yeah, you have to type in not 1, but 2 equations. I still have it typed in from my morning class. 4 plus the square root, and then 4 minus the square root. And it's kind of a self-check. Does it look like my vertex that you can't see? There we go. Ended up at 3, 4. Okay. That gives me confidence that this appeared right because it's in that right area. So for a sketch here, x-axis, y-axis. Okay. I know my parabola goes that way. And that's not the best because I should have it crossing the x-axis. Should have done that differently. But, that gives me an indication. Yep. And since that's at positive 8, we know it's either opening right or up, depending on which, where it is. Since the square's on y, it's a left-right. Okay. So some ideas of what I expect there. B real quick. What are we solving for again? Y. And what do you notice? There's one y term. So should that be a pretty easy one? Yeah, it should be. To get y by itself, I'm going to subtract the x squared over, add the 7x over, and add the 2 over. And then as I clean that up, I have 3y equals negative x squared plus 7x, and then 9 plus 2 makes it 11. Since it's 3y, what do I need to do? Divide by 3. And what I would do, since we're just going to punch this in on the calculator, is just make it one big fraction and put 3 underneath. Does that make sense? While I fight the computer. There we go.
It won't work if it's all over one side.
Huh?
It won't work if it's all over one side.
What do you mean?
Okay,
There you go. I see. Does that make I was understanding your question, but yeah, he's got the right answer there. Okay, when you graph this, guys, look, it's a parabola is going to have y equals negative x squared. It's going to open down. Yes, we actually get one that opens up or down today. Okay, so this does open down. I'll tell you another thing you can note on your drawings is you can try and find the vertex. Like I know this vertex is around 3.5 to 7, and then 7.5. Okay. Now I want to talk about C real quick, just because I'm running out of time. Notice what's different about this one. There's a y squared and a y. You know, up above, it was at y minus 4 squared. Then there was just a y. Guys, they gave us a hint. We are completing the square. Okay? So in order to complete the square, we want to keep all y terms together on one side. So I'm going to keep the y squared plus 2y, and I'm going to move everybody else over. So I'm going to add 6x and subtract 13 over to the other side. I'm going to leave a gap. Do you remember the gap? So I have y squared plus 2y blank equals 6x minus 13. Do you remember how to complete the square? B over 2 quantity squared is the number you add to not one, but both sides. Okay? So we end up doing a half of 2 is 1, 1 squared is 1. So you end up adding 1 to the left and to the right. Okay? You factor the left and then you solve kind of like you did the first one. I'll finish this up for notes. Finish your homework for tomorrow, okay? We'll talk about questions. This is y plus 1, quantity squared, equals 6x minus 12.
and there's some front side more than the back.
I'm going to square root. Y plus 1 equals plus or minus square root of 6x minus 12. I'm going to subtract 1. And y equals negative 1 plus or minus the square root of 6x minus 12. And this could also be written in factored form. Y equals negative 1 plus or minus the square root of 6 times x minus 2. And then when you graph that, it would go sideways. The homework is page 587, 7 through 10, 12 through 30 evens, 40, 42, and 46.
We're gonna